Okay, these are 13.1. This section is not covered in the book, so you are going to need this to figure it out. The first part is a review actually of chapter 6 in Algebra 1. So this is a review from before, but it's a necessary skill for what we are about to do in the geometry. So why not give it a try? See if you can remember how to complete the square. Mr. Lewis taught you this last year. So give that a try and fill it in, and then you can come back and check your answers. All right, now when we complete the square, again, I'm cutting out a lot of the good stuff we were doing in class. Some people were drawing the area model, the boxes, and saying, well, it's a square, so the length and width have to be equal to each other. So they took this middle term, put it in the diagonal part, said, well, those have to be equal because it's a square. That's how they were figuring this out. Again, we went more in depth in class, but it's basically half of this middle number, and then you square it. So half of 20 is 10, you square it. Half of negative 9 is 4.5, you square it. Then we talked about solving by completing the square. Yes, you learned how to solve these with many methods in Algebra 1. So you know the quadratic formula, you know factoring, but in particular I needed you to review completing the square. So from here to here, what I did was subtracted 21 from both sides. Then I wanted to complete the square of the left side. So I took half of 10, which is 5, squared it. That's 25 added to both sides. I then factored this left side. That turns into x plus 5 quantity squared, and this is 4. Now, because that's squared, I'm going to square root both sides. Once you square root, this goes into absolute value, and then you solve the absolute value equation. You get two answers, -3 and -7. You can see my work shown over here for the different problems. Over here is a no solution because the square root of a negative is not a real solution. Okay. We also looked at these on Desmos and their graphs. Again, in the video version, you're getting the shorter part. Okay, so the next thing we did is we looked at these. This is an equation of a circle. If you don't believe me, you can put it into Desmos. You can see the circle, but looking at it the way it is now, it's pretty difficult to figure out what the center and the radius are. They're not in that standard form we worked with earlier. So what we are going to do is make that happen. So, I have the answer right there. I moved the x's near each other, the y, and you can see the 18 I moved to the other side. Now I'm going to complete the square in blue, and since I'm adding something to the left side, I have to make sure I add it to the right side as well. So half of 4 is 2, 2 squared is 4, add that to both sides. I factor the left side, or the blue. The y, you could almost think of that as y minus 0, and 18 plus 4 is 22. So now it's in that standard form I needed. So the center is 2, 0, and the radius is the square root of 22. So you can try that on the next two problems and then come back and check your answer. So please push pause now, give it a try, and then come back and check your answer. Okay, here are the answers to these. If you need to look through the solutions, you can push pause because I won't be on this screen very long. Notice in problems 2 and 3, we had to complete the square on the x and the y, so you do need to add two different numbers to the right side. And you can, I tried to color code it to give you some ideas with that. So here are your answers to questions 2 and 3. If you're not sure where something came from, write that down in your notes and then you can come and ask me in class. All right, in the next part, again, we did this a little differently in class. In class, we actually graphed both of these. We let Desmos show us how many times they intersect. But I said, well, what are you going to do when you don't have Desmos? So you might want to even just come up with a plan. I think it's very clear that after what we just did, you could find the center and the radius of this circle and this circle. So how, if you knew the centers and you knew the radii of each circle, how do you think you could use that to determine how many points they intersected? Have some work shown here. So what I did in the first one, let me just explain it all, so I'll just delete that. I completed the square. This is the top equation. I put it in standard form. The bottom equation right here, I put that in standard form. I found the center of each one. I found, using the distance formula, the distance between those centers, and I found the radii of each one. You can see those there. and they intersect twice. So if you kind of look at that, the reason I know that is the distance of the centers was the square root of 65, which is roughly about 8.06. The sum of the radii is 11. So the distance from the centers is less than the sum of the radii. So that must mean they intersect twice. And I kind of drew a picture there. Okay, in the next problem I did something, I didn't really, let me actually undo that. You can try the next two and see what you can do using the same idea. So put them in standard form, find the centers, find the distance between the centers, look at the radii and the sum of the radii and see what that means. What is this going to look like when you compare the sum of the radii and the distance of the centers when they intersect only once? How would these numbers compare there? How would they compare if they didn't intersect at all? So push pause and try that now. Right. Here are the answers. I didn't show all the work. I think I can move that down too. So here the distance between the radii is 5. I'm sorry, the distance between the centers, the distance between the centers is greater than 5, which is greater than the sum of the radii. So center to center is, even if you extended the radii toward each other, there would still be an empty space in between. And in this one, the distance between the centers is exactly the sum of the radii, so that's 1 point of intersection. And we can talk about that more in class as well. So that is the end of the 13.1 kind of day 2 notes.